What do we have? Microevolution, the part of the title page of Chapter 17 of Crode 5e, and then macroevolution, part of the title page of Chapter 18. What's the difference between microevolution and macroevolution? Well, what does micro mean? It means evolution on a small scale evolution, microevolution. What does macroevolution mean? Well, macro means what? Large. So this would be large-scale evolution. Evolution on a large scale. What would be examples of each? Well, here's some of Darwin's finches, various species of finch on the Galapagos Islands. Would this be an example of microevolution or macroevolution? Pretty small scale. This would be microevolution. And what about this? I could have picked several trees that we showed you earlier, but just picked this one because it's what? The evolution of everything. Is this macroevolution? It's as macro as it gets, right? The evolution of everything from common ancestors. Descent with modification of all species. Everything is connected by common ancestry. Macroevolution. Now, is microevolution part of the origins controversy? It may surprise some of you, but no, it is not. The most ardent creationists would have little or no problem with anything in Chapter 17. And if you don't believe that, check it out. Chapter 17, Microevolution, no problem. No problem. Where the most ardent creationists get off the train is right between Chapter 17 and Chapter 18. So, with microevolution then, such as the evolution of Darwin's finches, no controversy, not part of the controversy. However, macroevolution, what about this? Is this controversial for many people? Yes, it is. There's a lot of people that don't buy this. There's no problem with micro, but a lot of problem for some people with macro. So, last thing about these is the source of genetic variation that's most crucial. What source of genetic variation is most crucial for microevolution? Well, what are the two sources of genetic variation that we talked about, the two major sources? There is what? Meiosis. What does it do to alleles? It shuffles alleles. Then there's what? Mutations. What do mutations do for alleles? They change the alleles. What about this right here that we see, these different species of finch in the Galapagos Islands? You think mostly meiosis, a shuffling of alleles, or mutation, a changing of alleles? Well, I'm thinking mostly which one? Small-scale evolution, shuffling of alleles will probably get this done, bringing out different combinations of alleles on the various islands. What about macroevolution? What source of genetic variation is most crucial for this? Meiosis that shuffles alleles or mutations? I usually ask for a vote in class. What do folks think? And then I say your textbook weighs in on the subject and we check it out. And what does it say in your textbook? Something like this. Here's the question. Which source of genetic variation is most crucial to macroevolution? Well, it says in Crode 5e, page 241, and the primary way major changes come about in species is through mutations. An example given on page 241 is no eyes to eyes. What's that all about? Well, the author says this. Eyes evolved along this particular branch, the animal kingdom branch, according to the concept of macroevolution. So things down here that didn't have eyes over time evolved in things up here that do have eyes. Now, are you going to get from no eyes to eyes simply by shuffling the alleles you already have? No. You'd be shuffling no eye alleles forever and still have no eyes. You must have new alleles, and the only way that alleles change in the concept of evolution is through mutations. That is the way alleles actually change. All right. We got it? That's it.